Hello everybody, I wish you're doing well. Today we will do a PowerMILL tutorial where we will learn how to create setups. So let's start by importing our workpiece. We can put it directly here. So as you know, we can take any type of folders into PowerMill. We can take cat products, we can take SolidWorks folders, we can take step, we can take STL, and the PowerMill will read them without a problem. So to start our tutorial, we will do as usual. We will firstly create our levels and sets. So we'll create two levels. So we will uh, name this first one box. This one, it will be this part, and we will call it vice 1. And this part will be vice 2. So to select this, so we'll do this, we will select it, and we will click on vice 2, or we'll acquire it on vice 1, and we will call it and we will acquire selected model geometry. So when we click here we will hide it. Then now we will select the second vice. What we can do, we can select from here, and we will say to acquire model geometry. Then we will have to select just these parts, and we will acquire them. Here, same thing, but we pay attention to not touch this, so we can do this. So this is it, and this will be the box. So we can put these two vices into clamps, so we will click on them and we will convert them to clamps. So like this. So we'll do this to so when we do toolpaths, they will ignore them since they are clamps. So it is this, and we'll let this as a level. So this is it. Then in this first vice, with this first vice, we will measure this distance to add it now next time. So we will measure from here with a constant z to here. Let's see how we have it. Is it a constant z? I don't know, so let's just see it. It is not a z, but it is a y. So let's just measure. So we click here and we'll select y, and we from here to here. So we have 20 millimeters. So now we will create box, so we will calculate it in not in active but in global transform. This is it, and in the positive y we will add 20 millimeters. So I will block the minimum and add plus 20, and it will be good here. So we can machine it. So let's accept. Then now what we will do is to for example, let's add also distance here to machine it. So let's add in this we can add also 20 millimeters. No, not add, but do minus 14 to add 20. So this is it. So we'll accept it like this. So now we'll create two setups. We'll name them directly 1 and 2. So we'll start by this one. We'll select it. We'll go into settings. So we will create a work plane for this setting. We will name it also 1. So let's create it here with the Z aligned on the top, not in this direction, but I want it like this. So I will twist on X. So let's twist in 20 degrees. Let's see it. 19 degrees, sorry. Let's see, that's good for us. So let's select our work plane. This is it. Then we will select our vice number 1, so we can do it like this. Then now we can add a tool, a machine tool, for example. We can add a toolpath. We can add connection. This with selecting some parts that we want to ignore or something else. We have a multitude of parameters here. We can add point distribution, start and end points, moves and clearance. So this is it. We have also point distribution, and we can add some thicknesses. So this is it. We can directly close and then go to settings here. So as we will do the same. So we will create. So let's see the second vice. Yes, we will create a Z like this. So let's create a work plane here. Yes, so it is the same. The Y is aligned. I don't want to align the Y, but it will be special. This Z who will be aligned in this. So we will twist in X. Let's put 90 degrees as the first. Let's just see if it works. No, I will put 180 more, so it will be aligned like this. So this is it. So let's select the second work plane. Now I will we have the box directly. We will select the second vice, and now same thing. We won't put anything here. Toolpaths, we can add them next time. So let's see them here. Connections, point distribution. So this is it. So yes, we will have this. So let's start machining with the first uh, setup. So we can simply create. We have to double click on it. Firstly, then we will create a tool, an end mill especially. So let's create an end mill of 32 with uh, 25 in length. Let's see, where is it? I don't know. Yes, so let's put a shank, bigger shank, or let's just let it like this. Let's create a holder, mm, a lower diameter like this, and upper diameter of 15, for example. And let's 25 if you wish in length, and 63 here, and 63 here. It will be like this, and overhang of 15 to be directly straight like this. So let's see firstly our toolpath here. Let's rapid moves and plunge moves. So to set up some rapid moves and uh, rapid moves and the others. So let's calculate them directly. Let's show them toolpath. They are good like this, so this is the best thing to do. So we can have them, for example, here. So we will go to this. We'll go on the setups. So we'll calculate here and apply them and accept. If they don't move, we can, for example, just create a toolpath. So let's create a city area clearance. We can face mill them, for example. Creating a toolpath, it will align directly. So with this face milling toolpath, we can, for example, select this surface to face mill it, and let's calculate. We'll have this. We can do one way or two ways by directional, so it will go and return, and step over we can put uh, 3 millimeters, for example. Let's see what will change. So we'll have less here. We can put the depth here. I don't know how much we have here. We can put 20 millimeters. It was 20, yes. Can put 5 millimeters in every step. So this is it. It's created. So we'll have a multiple machining. So let's hide these surfaces. We can go straight here. So we can simulate it. Oh, no. Can do the machinings like this. Yes, we can do in this direction, then in this direction. We can choose all this here in these parameters. So this is it. So we can create a second toolpath in this direction. So let's do the same toolpath, but in this direction. Let's face mill. Then now we will choose the second direction. It is the same, 120 millimeters. Then let's put XY expansion, for example, of 13 millimeters. Then let's put the same parameters, and we can, for example, calculate this to have slightly align this tool in and have the best position from the beginning. So let's calculate now. We'll have it like this. So to simulate, we can simulate it directly here. So now if we want to create a stock model, we can create a stock model with these two different toolpaths. We can import this one. Let's open it first. Can import it here. Then we can import this. So let's hide this toolpath, and we can calculate and see the uh, rest machining. So we can select this to see that it did this two surfaces. So this is it for the usage of toolpath. So I have to explain to you something that there is two approach that we can use in PowerMILL in machining. We can use setups with the rest machining like this, or there is a second method that I have shown you in another video where we can just use a stock model and export it and re-import it in a new project. But I prefer this method of setups, but there is a problem with this method of setups is when you import a machine tool here, you can't do collision check with you can do collision check. It is not that you can't do collision check, but you will find problems with the two setups superposed, because when you do collision check, uh, it they will give you problems that don't exist. You can ignore them, but sometimes it can you can have some problems with this. But I really like this method, and for its problem with the machine tool, you can see you can just uh, don't don't check the collision and check for them with CN directly in the block. So thank you for watching. See you soon.